Hello everyone, what if I tell you that the time is not the same everywhere in the universe? Right now, at this very moment, time is moving at a slightly different rate for astronauts in the space than it is for the people standing on the Earth. It sounds impossible, but it has been scientifically proven. Did you know that your gravity can slow down the time and that your GPS will stop working accurately if scientists ignored Einstein's theory of relativity? Every time you use your phone for directions, you are benefiting from one of the greatest discoveries in the physics. So, to this fascinating journey into one of the greatest mysteries in the universe, the time, every second of your life is guided by the time. We wake up according to the time, work according to time, celebrate birthdays according to time, and even measure the age of the universe using the time. Yet, despite its importance, scientists still can't fully answer one simple question: what exactly is the time? Most people think of the time as something shown by a clock or a calendar. However, time is much more than numbers on a watch. It is one of the fundamental parts of our universe. Without time, there would be no change, no movement, no history, and no future. Everything that happens from the birth of a star to the beating of your heart depends on the time. So in this video, we will explore 15 amazing facts about the time using simple language and real life examples. We will learn how Albert Einstein changed our understanding of time through this theory of relativity. We will discover why astronauts experience time differently from the people on the Earth and why GPS satellite must constantly correct their clocks. We will also examine the fascinating ideas such as time travel, black holes, beginning of the universe, and why time seems to pass more quickly as we grew older. Some of these topics are surrounded by the controversy. For example, many people believe that time travel is impossible, while others think it may one day become a reality. Science does not accept every popular claim, but does provides evidence for some surprising possibilities. Throughout this video, we will carefully separate the scientific facts from myths and explain what researchers currently know and what remains uncertain. As you watch this video, remember that every moment is valuable. Time is the only resource that cannot be replaced once it has passed. Money can be earned again, but a lost minute never returns. Appreciating the time encourages us to learn, grow, help others, and make meaningful choices. By the end of this journey, you may never look at a clock in the same way again. Now, the question is, what is time? Time helps us understand the change, motion, cause and effect, past, present, and the future growth of the universe. Before learning amazing facts about the time, we first need to understand what time actually is. This question sounds simple, but it has challenged philosophers, scientists, and mathematicians for thousands of years. Surprisingly, there is still no single definition that satisfies everyone. In everyday life, we think of time as something measured by the clocks and calendars. We use seconds, minutes, hours, days, months, and years to organize our life. These measurements help us schedule meetings, celebrate festivals, and understand history. However, these units are simply human inventions. They measure time, they are not time itself. From a scientific perspective, time is considered one of the fundamental dimensions of the universe, just like length, width, and height. According to the modern physics, every event happens at a specific place and at a specific time. Together, space and time form what scientists call space-time. This idea became famous after Albert Einstein introduced his theory of relativity early 20th century. His work showed that space and time are connected and that they can change depending on the speed and gravity. Another important idea is that the time helps us understand the order of events. For example, a seed grows into a tree, water freezes into ice, and a child becomes an adult. Time provides the sequence that allows these changes to happen. Without time, there will be no before and after. Human beings also experience time psychologically. Have you ever noticed that an enjoyable vacation seems to pass very quickly, while waiting in a long queue feels endless? This happens because the brain does not always perceive time at a constant rate. Emotions, attention, stress, and memories all influences our personal experience of time. Later in this video, we will explore this fascinating psychological aspect in more detail. Some people ask whether time is truly real or simply an idea created by the human mind. This question remains an active area of scientific and philosophical debate. Most physicists agree that time plays a measurable role in the laws of nature because experiments repeatedly confirm predictions involving time. At the same time, researchers continue investigating whether time emerges from even deeper physical principles that we do not yet fully understand. The important message is that the time is far more than a clock on the wall. It is woven into every part of existence, from the movement of planets to the smallest particles inside atoms. Understanding the time helps us understand the universe and ourselves. Finally, there is also a personal lesson. Every person receives the same 24 hours each day, but the choices we make determine how meaningful those hours become. Time is not only something to measure, it is something to value. Using it wisely, learning continuously, showing gratitude, and spending time with loved ones are some of the best ways to honor these precious resources. Time is not the same everywhere. Time is relative, not absolute. Gravity and speed affects the time. Albert Einstein changed our understanding of time. Clocks can tick at different rates. This has been confirmed through scientific experiments. Time is what a clock measures, but not every clock measures it in the same way. Many people believe that the time passes at exactly the same speed everywhere. It feels natural to think that 1 second on Earth is identical for everyone in the universe. However, one of the greatest discoveries in the modern science showed that this idea is not completely true. In 1905, Albert Einstein introduced his theory of spatial relativity. Later, in 1915, he expanded these ideas through the theory of general relativity. Together, these theories completely changed our understanding of space and time. Einstein explained that the time is not fixed or universal. Instead, it depends on how fast something is moving and how strong the surrounding gravity is. Imagine two perfectly accurate clocks. One clock remains on the Earth while the other travels into space at an extremely high speed. When the space clock returns, it will show slightly less time has passed than the clock on the Earth, although the difference may be tiny or ordinary spacecraft. The effect is real and has been measured many times using highly accurate atomic clocks. Scientists have also confirmed this idea by placing precise clocks on airplanes and satellites. After completing their journeys, these clocks show the small but measurable differences compared with the clocks that remained on the Earth. These experiments proved that Einstein's predictions were correct. A common controversy is that some people think relativity is only a mathematical idea with no practical values. The evidence says otherwise. Technologies that millions of people use every day depends on these corrections. Without accounting for relativity, a system like GPS would quickly become inaccurate by several kilometers. Another misunderstanding is that relativity means everything is relative. That is not what Einstein means. The laws of physics remain consistent. What changes is how observers measure time and space when they move differently or experience different gravitational conditions. This discovery teaches an important lessons beyond the science. So reality is not always what it first appears to be. Sometimes we need evidences, careful observations, and an open mind before reaching to the conclusions. Great discoveries happen when people are willing to question old assumptions and test new ideas. Be grateful that human curiosity has expanded our understanding of the universe. Every scientific breakthrough reminds us that learning never ends, and the universe is often far more amazing than we imagine. If the speed can change time, then gravity can also influence it. Let's discover how gravity literally slows the passage of time. Gravity slows the time. Strong gravity slows time. Clocks near Earth tick slightly slower than the clocks farther away. Black holes create the strongest known time dilation. This phenomenon is called gravitational time dilation. Gravity is one of the most familiar forces in everyday life. It keeps us standing on the ground, controls the movement of planets, and causes objects to fall towards Earth. But gravity does something even more surprising. It changes the speed of time. According to Einstein's general theory of relativity, gravity bends space and time together. The stronger the gravitational field, the more slowly the time passes. This effect is known as gravitational time dilation. Although this sounds unbelievable, scientists have measured it with extraordinary precision. For example, clocks placed on mountains tick slightly faster than identical clocks at sea level because gravity is a little weaker at higher altitudes. The difference is extremely small, but modern atomic clocks are accurate enough to detect it. One of the most fascinating places where this effect becomes dramatic is near a black hole. The black holes have such intense gravity that time slows enormously close to them. If a person could safely orbit near a massive black hole and later return to Earth, much more time could have passed for people on the Earth than for the traveler. This idea becomes popular through the movie Interstellar, although the film exaggerated some aspects for storytelling. Interestingly, many of its scientific concepts were based on real calculations developed by physicists. Some people argue that these ideas belong only to the science fiction. However, the underlying science has been repeatedly tested. Satellites in the orbit experiences slightly weaker gravity than people on the Earth's surface, so their clocks tick at a little faster. Engineers must correct for this difference every day to keep navigation systems accurate. A common misconception is that the gravity only affects the objects and not the time. Modern experiments have shown that the gravity affects both. This is one of the reasons Einstein's remains one of the greatest achievements in the science. There is also a valuable life lesson hidden in this discovery. Nature often works in ways that are invisible to our eyes. Just because we cannot directly see something doesn't mean it is not real. Scientific progress depends on observation, careful measurement, and humility in the face of evidence. Be thankful for the scientists who spent years testing these ideas with patience and precision. Their work allows us to build technologies that improves communication, transportation, and our understanding of the cosmos. Gravity changes time, but so does another surprising factor, the speed. Let's see what happens when something travels close to the speed of light. Have you ever imagined traveling so fast that you could return to the earth younger than your friends? This sounds like a story from a science fiction movie, but according to the modern physics, it is based on real scientific principles. Einstein's special theory of relativity tells us that as an object moves faster and faster, time for that object passes more slowly compared with someone who is standing still. This effect becomes noticeably only when the object's speed approaches the speed of light, which is about 3 lakh kilometers per second. One of the best known examples is the twin paradox. Imagine two identical twins. One remains on Earth while the other travels through space in a very fast spacecraft. After many years, the traveling twin returns home. According to relativity, the astronaut twin will have aged less than the twin who stayed on the Earth. Although this example is simplified, it illustrates how motion can affect the passage of time. Scientists have tested this principle many times. Tiny particles called muons created high in Earth's atmosphere survive much longer when they move at extremely high speeds than they would if time flowed at the same rate for them. Particle accelerators around the world also confirms these predictions with remarkable accuracy. A common controversy is whether humans could use this effect for future interstellar travel. In theory, astronauts traveling close to the speed of light could experience only a few years while decades or even centuries pass on the Earth. The challenge is that the current technology cannot accelerate large spacecraft anywhere near light speed. Therefore, while the physics is sound, the engineering remains far beyond our present capabilities. Another misunderstanding is that objects can travel faster than light. According to our current understanding of physics, no object with a mass has been shown to exceed the speed of light. Scientists continue exploring new ideas, but no verified experiment has overturned this principle. Beyond physics, this fact reminds us that the universe is far more extraordinary than everyday experience suggests. The rules that govern galaxies, stars, and tiny particles often challenge our intuition. Instead of fearing new knowledge, we should welcome it with curiosity and critical thinking. Take a moment to appreciate how science allows us to explore ideas that once seemed impossible. Every discovery expands our understanding of reality and inspires future generations to ask even bigger questions. Now that we understand how gravity and speed can change time, our next fact explores another great mystery. Why does time always seems to move forward and never backward? Time seems to move only from the past to the future. This is called the arrow of time. The concept is closely connected to entropy. Broken objects do not naturally rebuild themselves. Scientists are still studying why this direction exists. The future is created one moment at a time, but the past remains our greatest teacher. Have you ever wondered why time always seems to move forward? We remember yesterday, but we cannot remember tomorrow. A broken glass can shatter into hundreds of pieces, but those pieces never suddenly come together to form the original glass. These everyday observations are connected to one of the deepest ideas in physics, known as the arrow of time. The arrow of time refers to the direction in which time appears to flow from the past towards the future. Scientists believe this direction is closely related to a concept called entropy, which comes from the second law of thermodynamics. In simple terms, entropy is a measure of disorder. Over time, natural systems tend to move from more organized states to less organized ones unless energy is added to maintain order. Imagine building a sand castle on the beach. With time, wind and waves slowly destroys it. However, you will never see grains of sand naturally arranging themselves into a perfect sand castle without someone building it. This illustrates how entropy increases over time. Many people ask an interesting question. If the laws of physics often work both forward and backward in mathematical equations, why do we experience time in only one direction? Scientists are still searching for a complete answer. One leading idea is that the universe began in an extremely ordered state during the Big Bang. Since then, entropy has been increasing, giving time its apparent direction. A common misconception is that the time itself pushes events forward. In reality, the scientist describes the arrow of time as an observation about how physical processes get unfolded. Time is closely linked to the change, and entropy helps explain why certain changes occurs naturally in one direction. This topic has also inspired philosophical discussions. Some people wonder whether the future already exists or whether it is continuously being created. Different scientific and philosophical viewpoints explore this question, but there is currently no universally accepted answer. The positive lesson from this fact is that while we cannot change the past, we can influence the future through our actions today. Every decision we make becomes part of tomorrow's history. Instead of worrying about what cannot be reversed, we can focus on learning, improving, and creating meaningful experiences. Be grateful for every new day. Time moves forward whether we are ready or not. So, using each moment wisely is one of the greatest gifts we can give ourselves and others. If time always moves forward, can it ever completely stop? The next fact explores one of the most fascinating questions in the modern physics. Time can slow dramatically under extreme conditions. Near the speed of light, time slows significantly. Near black holes, gravity also slows time. Scientists have not observed time completely stopping for ordinary objects. This remains an active area of research. The idea of time stopping has fascinated people for centuries. It appears in movies, novels, and television shows where characters freeze the world around them while continuing to move freely. Although this makes for exciting entertainment, real science tells a more complicated story. According to Einstein's theory of relativity, time can slow down under certain conditions. When an object moves at a speed close to the speed of light, time passes more slowly for that object compared with someone at rest. Likewise, extremely strong gravity, such as the gravity near a black hole, also slows the passage of time. Imagine an astronaut approaching a massive black hole while another astronaut watches from far away. The observer would see the astronaut's clock ticking more and more slowly as they approach the black hole. To the distant observer, it might even appear that time has almost stopped near the event horizon. However, from the astronaut's own perspective, time would continue normally. This difference illustrates how time depends on the observer's frame of reference. A common controversy is the claim that scientists have proved time completely stops inside the black holes. The truth is more careful than that. Our current theories describe what happens near a black hole very well, but the exact conditions at the center hole, the singularity remains unknown because general relativity and quantum mechanics are not yet fully united into one theory. Another misconception is that humans could simply freeze time and walk around unaffected. There is no scientific evidence supporting this idea. Time behaves according to the law of physics, and those laws apply to everyone and everything. Despite these limitations, studying extreme environments teaches us important lessons about the universe. Black holes, neutron stars, and high-speed particles allow scientists to test ideas that would otherwise remain impossible to explore. This fact also reminds us to appreciate the present. While physics explores extraordinary possibilities, our everyday life continue one moment after another. Instead of wishing time would stop, we can learn to enjoy meaningful moments with family, friends, learning, and personal growth. Gratitude grows when we recognize that every second is unique. Once a moment has passed, it becomes part of our story forever. If time can slow dramatically, another exciting question naturally follows. Could we ever travel through the time itself? Forward time travel is supported by relativity. Backward time travels remains hypothetical. Wormholes are one proposed idea. No verified evidence exists for human time travel. Scientists continue exploring the possibilities. Always remember, the science encourages imagination, but it demands evidence. Time travel is one of the most popular ideas in the science fiction. Movies often shows people traveling hundreds of years into the past or future with the push of a button. But what does real science say? The surprising answer is that a form of forward time travel already exists. As we learned earlier, astronauts traveling at extremely high speeds experiences time more slowly than people on the earth. This means that when they return, they have effectively traveled a little farther into Earth's future than everyone else. Although the difference is usually tiny with current spacecraft, the effect has been confirmed through experiments. Traveling backward in the time, however, is a very different matter. Scientists have proposed several theoretical ideas, including wormholes, which are hypothetical tunnels connecting distant points in the space and possibly time. According to some mathematical solutions in Einstein's equations, wormholes might exist under very special conditions. However, no holes has ever been observed, and many questions remain about whether they could stay stable long enough for anything to pass through them. One major controversy concerns the famous grandfather paradox. Imagine traveling into the past and accidentally preventing one of your grandparents from meeting the other. If that happened, you might never be born. So, who traveled back in the time? Such logical contradictions shows why backward time travel presents enormous challenges. Some scientists have suggested ideas like the Novikov self-consistency principles, which proposes that events in the past cannot be changed in ways that create contradictions. Others explore possibility of parallel universes where changing the past might create a different timeline instead of altering your own history. At present, these remains speculative concepts rather than established scientific facts. It is important to separate scientific theories from fictional stories. Science welcomes creative ideas, but every claim must eventually be tested through observations and experiments. So far, no verified evidence shows that humans have traveled backward through time. The excitement surrounding time travel demonstrates the power of human imagination. Throughout history, many ideas once considered impossible eventually became reality after scientific progress. At the same time, science teaches us patience. Not every fascinating idea turns out to be physically possible. There is also a valuable lesson for daily life. While we cannot change yesterday, we can learn from it. Instead of wishing to rewrite the past, we can use our experiences to build a better future. Every decision we make today becomes the foundation for tomorrow. Be grateful for the present moment. It is the only point in the time where we can truly act, learn, create, and make a positive differences. We have explored extraordinary physics, but time is not only experienced by the universe, it is also experienced by the human brain. Next, we will discover why time seems to pass faster as we grew older. Time perception changes with the age. The brain notices new experiences more strongly than familiar routines. Childhood often feels longer because everything is new. Adults experience many repeated activities, making time seems to pass quickly. This is a psychological effect, not a change in physical time. Life does not become short. Our experience of it becomes different. Ever wondered why summer vacations seemed to last forever when you were a child, but now an entire year feels like it passes in the blink of an eye? Almost everyone experiences this feeling, yet the clock measures time in exactly the same way. The difference lies not in physical time, but in how our brain perceives time. When we are children, almost everything is new. Our first day at school, our first bicycle ride, our first holiday, and our first friendship creates powerful memories. The brain pays close attention to these new experiences because they help us learn about the world. Since the brain stores many detailed memories from these events, looking back makes that period of life seems longer. As we grew older, many activities becomes familiar. We travel the same roads, follow similar work routines, and repeat many daily habits because the brain does not need to process every familiar event with the same level of attention. Fewer detailed memories are being created. Later, when we look back, that period seems shorter because there are fewer memorable moments stored in our memory. Psychologists have studied this effect for many years. One explanation is called the novelty theory. According to this idea, the more new experiences we have, the richer our memories become. Rich memories make periods of time feel longer when we remember them. Another interesting factor is proportion. For a 5-year-old child, 1 year represents 20% of the entire life. For a 50-year-old adult, 1 year represents only 2% of their life. This differences may also influence how long a year feels. A common misconception is that the time actually speeds up as we age. Science tells us this is not true. The Earth's rotation remains constant. Clocks continue ticking at the same rate, and the laws of physics do not change because of age. What changes is our perception of time. This understanding offers an important life lesson. If we want life to feel richer and more meaningful, we should continue learning, exploring new places, meeting new people, reading new books, and developing new skills. Novel experiences keep the brain active and create a lasting memories. Gratitude also plays a role. When we pause to appreciate everyday moments, a sunrise, a conversation with family, or a walk in nature, we become more aware of the present instead of rushing through it. Mindfulness helps us experience life more deeply rather than simply watching it pass. Instead of asking, where did the time go? Perhaps we should ask, how can I make today's time meaningful? The answer often lies in curiosity, learning, kindness, and gratitude. While age changes our perception of time, emotions can change it even more dramatically. Let's discover how your brain can stretch or shrink time in surprising ways. The brain does not always experience time accurately. Fear can make seconds feel much longer. Enjoyable activities often make hours feel like minutes. Stress, boredom, meditation, and concentration all influences time perception. Time perception is created by the brain, not by the clock. The clock measures time, the brain experiences it. Imagine waiting outside an examination hall. 5 minutes may feel like half an hour. Now imagine spending time with the close friends or enjoying your favorite hobby. Suddenly, several hours seems to disappear almost instantly. These everyday experiences shows that our brain does not always experiences time in the same way. Scientists call this time perception, and it depends on how the brain processes information rather than how fast the clock moves. The physical world continues at the same pace, but our mental experience changes according to our emotions, attention, and level of activity. One of the strongest influences on the time perception is fear. During dangerous situations, many people report that everything seems to happen in the slow motion. Researchers believe this doesn't mean time actually slowed down. Instead, the brain becomes extremely alert and processes much more information in a very short period. Later, because so many memories were recorded, the event feels as though it lasted much longer. The opposite effect occurs during activities that psychologists call as flow states. A flow state happens when you become deeply focused on something you enjoy, such as painting, playing music, solving problems, writing, coding, or playing sports. During these moments, your attention becomes completely absorbed in the activity. As a result, you may lose track of time and feel surprised when several hours have passed. Stress and boredom also affect the time perception. Waiting in traffic, standing in a long queue, or doing repetitive work often makes time feel painfully slow because the brain focuses on every passing moment. In contrast, exciting conversations, travel, learning, and creative activities keep the mind engaged, making time seems to pass quickly. Some people wonder whether meditation changes time. Research suggests that mindfulness meditation can alter the way people experience the present moment. Many practitioners report feeling calmer and more aware, with less anxiety about the past or future. Although meditation does not change physical time, it can improve our relationship with it. A common misconception is that the brain contains a single clock. In reality, the scientists believe multiple brain regions work together to estimate time, attention, movement, and memories. This makes time perception a complex and fascinating subject that researchers continue to study. The practical lesson is simple but powerful. Since our experience of time depends partly on how we live, we can improve our life by choosing meaningful activities, learning new skills, helping others, exercising, reading, creating, and spending quality time with the loved ones makes life feel richer and more memorable. Be grateful for the present moment because it is where life actually happens. We cannot relive yesterday and tomorrow has not yet arrived. The greatest gift we have is the opportunity to use today's time wisely. So far, we have explored how people experience time. Next, we move into one of humanity's greatest scientific achievements, the invention of atomic clocks, the most accurate timekeeping devices ever built. Atomic clocks are the most accurate clocks ever created. They measure time using atoms instead of gears. Modern atomic clocks lose less than 1 second over millions of years. They support GPS, telecommunications, banking, and scientific research. Precision timekeeping is essential for modern civilization. The more accurately we measure time, the better we understand the universe. For thousands of years, humans have searched for better ways to measure the time. Ancient civilizations used the movement of the sun, shadows, and stars. Later, people invented water clocks, hourglasses, pendulum clocks, and mechanical watches. Each invention improved accuracy, but modern science requires something even more precise. Today, the most accurate clocks in the world are called atomic clocks. Unlike ordinary clocks that depends on moving hands or electronic circuits, atomic clocks measures the natural vibrations of atoms. The most commonly used atom is cesium-133. Scientists discovered that this atom vibrates at an incredible stable frequency. In fact, 1 second is officially defined as 91926317770 vibrations of a cesium-133 atom. This extraordinary precision allows atomic clocks to keep time with remarkable accuracy. Some of the newest optical atomic clocks are so precise that they would lose less than 1 second over billions of years. Such accuracy may seem unnecessary, but it is essential for many technologies we depend on every day. For example, the GPS satellites uses atomic clocks to calculate your exact position. Mobile phone networks synchronize signals using precise timing. Internet communication, financial transactions, scientific experiments, weather forecasting, and even electricity distribution relies on accurate clocks working together around the world. The common misconception is that the atomic clocks contains radioactive material or are dangerous. This is not true. Atomic clocks simply observe the natural behavior of atoms. They do not explode like nuclear devices, nor do they create harmful radiation for the users. Scientists continue improving these clocks because even tiny improvements help answer important scientific questions. Modern optical clocks are being used to test Einstein's theory of relativity with greater precision and to study whether the fundamental constants of nature remain constant over the time. This fact teaches us an important lesson about the progress. Great achievements often comes from improving the small details. Measuring 1 second more accurately may seem like a tiny step, but it has transformed the communication, application, medicines, and scientific discovery around the world. There is also a personal lesson. Just as atomic clocks remain consistent and reliable, we can build trust by being dependable in our daily life. Small habits practiced consistently, often produces extraordinary results over time. Be grateful for the generations of scientists, engineers, and inventors whose dedication allows modern society to function smoothly. Their work reminds us that the precision, patience, and curiosity can change the world. One of the greatest everyday applications of atomic clocks is the technology many of us use daily, and that is the GPS navigation. GPS measures travel time of radio signals. Satellites carry highly accurate atomic clocks. Relativity corrections are required every day. Without these corrections, navigation errors would grow rapidly. Time makes global positioning possible. Every accurate journey begins with an accurate time. Imagine using your smartphone to find the quickest route to a new destination. Within seconds, your location appears on the screen with impressive accuracy. Most people think GPS works because of satellites alone, but the real secret behind GPS is the time. The global positioning system consists of dozens of satellites orbiting the Earth. Each satellite continuously broadcasts a signal containing the exact time the signal was transmitted. Your smartphone receives signals from several satellites at the same time. Because radio waves travel at the speed of light, your phone calculates how long each signal took to arrive. By comparing these travel times from multiple satellites. It determines your precision location through a mathematical process called trilateration. Here is where Einstein's theories becomes essential. Satellites orbit far above Earth, where gravity is slightly weaker than it is on the ground. According to general relativity, clocks in weaker gravity tick slightly faster. At the same time, satellites move at very high speeds, and according to spatial relativity, moving clocks tick slightly slower. Engineers must account for both effects. When these two effects are combined, satellite clocks gain about 38 microseconds each day compared with clocks on the Earth. This difference seems tiny, but because light travels so fast, even a small timing error would create navigation errors of several kilometers within a single day. A common misconception is that the GPS is simply a map stored inside your phone. In reality, GPS is an extraordinary combination of satellite engineering, mathematics, atomic clocks, and Einstein's theories. Every successful navigation depends on incredibly precise measurements of time. Some people question whether relativity has practical value outside scientific research. GPS provides one of the clearest answers. If engineers ignored Einstein's equations, GPS would become unreliable very quickly. This is one of the strongest examples of how abstract scientific discoveries eventually improve everyday life. This story teaches us that knowledge gained through curiosity often finds unexpected applications. Einstein was not trying to invent smartphone navigation, he was simply trying to understand the nature. Decades later, his discoveries became essential for billions of people worldwide. This personal lesson is equally inspiring. Learning may not always produce immediate rewards, but knowledge often creates opportunities far beyond what we first imagine. Investing time in education, curiosity, and problem solving can produce benefits for future generations. Be grateful that scientific cooperation across many countries has created technologies that connect people, improve safety, and make travel easier than ever before. We have explored how humans measure time with incredible accuracy. Now let us step back and ask a much bigger question. How old is time itself? Have you ever looked up at the night sky and wondered how old the universe really is? Today, scientists estimate that our observable universe is approximately 13.8 billion years old. This remarkable number is one of the greatest achievements of modern astronomy and physics. The story begins with the Big Bang, the event that marks the beginning of the observable universe. Contrary to a common misunderstanding, the Big Bang was not an explosion into empty space. Instead, it was the rapid expansion of space itself from an extremely hot and dense state. As space expanded, it cooled, allowing particles, atoms, stars, galaxies, and eventually the planets to form. How do scientists know the age of the universe? They use several independent methods that support one another. One important clue comes from the expansion of the universe. In the 1920s, astronomer Edwin Hubble discovered that distant galaxies are moving away from us. This observation showed that the universe is expanding. By measuring how fast galaxies move apart and combining that information with other observations, scientists can estimate how long the expansion has been occurring. Another powerful source of evidence is the cosmic microwave background radiation, often called the afterglow of the Big Bang. This faint radiation fills the universe and provides a snapshot of the cosmos when it was only about 380,000 years old. Space missions such as COBE, WMAP, and PLAN have measured this radiation with extraordinary precision, helping scientists refine the age estimate. One of the most fascinating ideas in the astronomy is that looking farther into space is actually looking backward in the time. Light travels at a finite speed, about 3 lakh kilometers per second. When we observe a galaxy 1 billion light years away, we see it as it existed 1 billion years ago because its light has taken that long to reach us. In this sense, powerful telescopes are also time machines that allow us to study the ancient universe. A common controversy is whether the Big Bang explains what happened before the universe began. Current scientific theories describes the evolution of the universe extremely well from a tiny fraction of second after the Big Bang onwards. However, what happened before that, or whether the word before even has meaning in this context, remains one of the greatest unanswered questions in the physics. The positive lesson is that humanity has achieved something extraordinary. By combining mathematics, observation, engineering, and curiosity, we have learned the approximate age of the entire universe while living on a small planet orbiting an ordinary star. Be grateful for the gift of curiosity. Every generation builds upon the discoveries of those who came before, allowing humanity to understand more of the magnificent universe we all share. If the universe began with the Big Bang, another profound question naturally arises. What if anything existed before it? That mystery is our next destination. The greatest discoveries often begin with the courage to say, we don't know yet. One of the biggest questions people ask is what happened before the Big Bang? It is a fascinating question because we naturally think that every event must have something before it. Before yesterday came the day before a person's birth came pregnancy, before a tree grew, there was a seed. Our daily experience teaches us that every beginning seems to have an earlier cause. However, the modern physics suggests that the Big Bang may be different. According to Einstein's general theory of relativity, space and time are connected. If space itself began expanding during the Big Bang, then time may also have begun at that moment. If this idea is correct, asking what happened before the Big Bang may be similar to asking what is north of the North Pole. The question assumes there is something beyond the starting point, but there may not be. Scientists have proposed several theories to explore this mystery. One idea is the quantum gravity theory, which attempts to combine Einstein's theory of gravity with quantum mechanics. Another idea is the Big Bounce theory, which suggests that the universe may have gone through repeated cycles of contraction and expansion instead of beginning only once. According to this model, a previous universe might have collapsed before expanding again into the universe we observe today. Another interesting proposal comes from inflation theory. This theory explains that the universe expanded extremely rapidly during a tiny fraction of a second after the Big Bang. Some versions of inflation suggest that our universe could be only one bubble in a much larger multiverse containing many universes with different physical properties. While these ideas are mathematically interesting, they have not yet been confirmed through direct observation. A common controversy is that the people sometimes present these theories as established facts. It is important to distinguish between scientific theories supported by evidence and speculative ideas that are still being investigated. Science progresses by testing ideas, not by accepting them simply because they sound exciting. Some people also think whether science and philosophy can both contribute to this discussion. The answer is yes. Science investigates questions through observation, measurement, and experiments. Philosophy explores questions about meaning, logic, and existence. These fields often complement one another by encouraging deeper thinking from different perspectives. The positive lesson from this mystery is that not knowing is not a weakness. Throughout history, admitting uncertainty has often been the first step towards great discovery. Scientists continue to ask difficult questions because curiosity drives progress. Be grateful that humanity lives in an age where powerful telescopes, satellites, and advanced mathematics allows us to explore questions that previous generations could only imagine. Every new discovery reminds us how much we have learned and how much still remains to be discovered. We have explored one of science's greatest mysteries. Now let's examine another fascinating question. Does time actually exist, or is it simply a way humans describe the changes? The universe often asks the questions that take generations to answer. After learning about relativity, black holes, atomic clocks, and the Big Bang, we arrive at one of the deepest questions in modern science and philosophy. Does time really exist? At first, this question may seem strange. We experience time every day. We celebrate birthdays, watch clocks, and remember yesterday while planning tomorrow. It feels obvious that time is real. However, when physicists study the universe at its deepest levels, the nature of time becomes much more complicated. One viewpoint is that the time is fundamental. According to this idea, time is one of the basic building blocks of reality, just like space, energy, and matter. Einstein's theory of relativity treats time as part of the fabric of space-time, and countless experiments have confirmed its predictions. Atomic clocks, GPS satellites, and particle accelerators all demonstrate that time behaves exactly as modern physics predicts. Another viewpoint suggests that time may emerge from more fundamental physical processes. Some researchers studying quantum gravity believe that the deepest laws of nature may not contain time in the way we experience it. Instead, time might appear naturally as complex systems evolve. This idea is still under investigation and has not been confirmed. Philosophers have also developed different ways of thinking about time. The presentism view argues that only the present moment truly exists. The past has gone and the future has not yet happened. Another idea, often called the block universe theory, suggests that the past, present, and future may all exist together as different parts of space-time. According to this interpretation, our experience of time flowing may be related to how human consciousness experiences the reality. A common controversy is the misunderstanding that because scientists debate the nature of time, they do not understand time at all. This is incorrect. Scientists understand many aspects of time extremely well. Technologies such as GPS, satellite communication, and particle physics rely on precise predictions involving the time every day. The debate concerns the deepest philosophical and physical meaning of time itself, not whether clocks work. Another misconception is that unanswered questions mean science has failed. In reality, unanswered questions are what drive scientific progress. Every important discovery begins with curiosity and careful investigation. Science does not claim certainty without evidences. Instead, it continually improves our understanding as new observations become available. There is an inspiring lesson here. It is perfectly acceptable to say, I don't know yet. In fact, this attitude has led to some of the humanity's greatest discoveries. Curiosity, humility, and a willingness to learn are qualities shared by many of history's greatest scientists. As individuals, we can apply the same principle. Instead of making quick assumptions, we can seek evidences, remaining open to new information, and respect different viewpoints while evaluating them critically. Be grateful for the opportunity to live during an era of extraordinary discovery. Humanity has already uncovered remarkable truths about the universe, yet the greatest mysteries may still lie ahead. Have you ever tried to catch a fly with your hand? Most of the time, it escapes before your hand even reaches it. Many people think flies are simply faster than humans, but there is another interesting explanation. Scientists believe that some animals experiences the passage of time differently because their brains process information at different speeds. Our eyes and brain work together to create a continuous picture of the world. However, this picture is actually made from many tiny visual updates every second. Scientists call this temporal resolution. Animals with higher temporal resolution can process more visual information in the same amount of physical time. For example, many birds can react very quickly while flying through the forest. Dragonflies catches insects in mid-air with remarkable precision. Flies often avoid danger almost instantly. Their brains process rapidly changing information much faster than ours, making fast-moving events appear easier to respond. This doesn't mean physical time passes differently for animals. The clock measures the same seconds for every living creature on the earth. What changes is how much information each brain can process during that seconds. In simple words, some animals experiences more frames of reality each second than humans do. Scientists study this phenomena by measuring something called the critical flicker fusion frequency. Imagine a light flashing on and off very quickly. Humans eventually see the flashing light as steady because our brains cannot process the flashes fast enough. Some birds and insects continue seeing individual flashes at much higher speeds. This shows that their brains process visual information more rapidly. A common misconception is that the animals are smarter because they react faster. Intelligence and reaction speeds are different things. Human beings excel at language, abstract thinking, creativity, mathematics, and long term planning, while many animals are specialized for survival in their own environments. This fascinating fact teaches us an important lesson about perspective. Every living creature experiences the world in its unique way. We should not assume that our own experience is only correct one. Nature has evolved countless solutions for different environments. The diversity of life reminds us to respect animals and appreciate the incredible variety of the natural world. Every species has developed remarkable abilities that helps it to survive. Be grateful that science continues revealing these hidden wonders. The more we learn about other living beings, the more we appreciate the richness and complexity of life on the earth. Different creatures experience time differently, but what about the universe itself? The universe measures time from trillions of a second to billions of years. One of the most amazing facts about the universe is the enormous range of time scales over which events occur. Some processes happen to so quickly that they are measured in trillions or even quadrillions of a seconds. Others unfold over billions of years. Let's begin with one of the fastest known things in the nature, the speed of light. Light travels through space at approximately 3 lakhs kilometers per second in a vacuum. This speed is so great that light can travel around the Earth more than 7 times in a single second. According to our current understanding of physics, nothing with mass has been observed traveling faster. Scientists also study incredibly fast events inside atoms and molecules. Chemical reactions can begin within femtoseconds, which are 1 billionth of a second. Specialized lasers allows researchers to observe these tiny intervals, helping us better understand chemistry, biology, and material science. At the opposite extreme are some of the slowest processes in the universe. Stars like our sun live for billions of years. Our sun is approximately 4.6 billion years old and is expected to continue producing energy for about another 5 billion years. Galaxies evolve over even longer periods as the stars are born, age, and eventually disappear. Continents on Earth also move extremely slowly due to plate tectonics. Mountains rise over millions of years, while rivers gradually shape landscapes through erosion. These slow processes remind us that dramatic changes often occur through countless tiny steps rather than sudden events. Common misconception is that the fast processes are always more important than the slow ones. In reality, both are essential. The rapid reactions inside living cells allows our bodies to function, while slow geological and astronomical processes creates planets, mountains, and entire galaxies. Another interesting point is that our human lifespan occupies only a tiny fraction of the universe's timeline. This realization can inspire both humility and curiosity. Although our life are relatively short compared with the cosmic history, we possess the remarkable ability to study events spanning billions of years through the science. The practical lesson is that the progress happens at different speeds. Some goals can be achieved quickly, while others require patience, consistency, and long-term efforts. Nature teaches us that meaningful changes often takes time. Be grateful for every stage of life's journey. Whether progress is fast or slow, every step contributes to the growth. Patience, persistence, and curiosity allows us to accomplish things that once seemed impossible. The future of time remains one of humanity's greatest mysteries. One of the biggest questions in the cosmology is whether time itself will ever come to an end. This question is closely connected to another mystery. How will the universe end? Scientists have proposed several possibilities based on current observations, but no final answer has yet been confirmed. The most widely accepted idea today is called the heat death of the universe. According to this theory, the universe will continue expanding for an extremely longer time. Eventually, stars will use up their fuel, galaxies will grow darker, and energy will become spread almost evenly throughout the space. When no useful energy remains to perform work, the universe will reach a state of maximum entropy. Although the time would still exist in this scenario, very little would happen because almost all physical activity would have stopped. Another possibility is the big crunch. If gravity were strong enough to overcome cosmic expansion, the universe might eventually stop expanding and begin collapsing back towards a very dense state. Some scientists once considered this idea lightly, but current observations suggest that the expansion of the universe is actually accelerating, making the Big Crunch less probable according to present evidence. A third idea is the Big Rip. This theory proposes that the mysterious force known as dark energy could become increasingly powerful over the time. If this happened, galaxies, stars, planets, and eventually even atoms could be pulled apart. This is a speculative idea and depends on the properties of dark energy that scientists do not yet fully understand. Some researchers also explore other possibilities, including cyclic universes that repeatedly expand and contract or entirely new physics that could change our current understanding. These ideas remains active areas of research. A common misconception is that the scientists know exactly how the universe will end. In reality, they continue collecting evidence using powerful telescopes, satellites, and mathematical models. Scientific knowledge grows through observation and testing, and future discoveries may improve or even change today's theories. This topic reminds us of the incredible scale of the universe. Human civilization has existed for only a tiny fraction of cosmic history. Yet, we have developed the ability to investigate events billions of years into both the past and the future. There is also an important personal lesson. While we naturally wonder about the distant future, our greatest opportunity lies in the present. We may not control the destiny of the universe, but we can influence our own life and the life of those around us through kindness, learning, creativity, and responsible choices. Be grateful that we are able to ask such profound questions. Curiosity is one of humanity's greatest strengths, and every generation contributes new knowledge that helps us better understand the magnificent universe we call as home. Knowledge grows when myths are replaced by the evidences. Throughout history, people have created many stories, beliefs, and misconceptions about the time. Some of these myths come from the science fiction, while others result from misunderstanding scientific discoveries. Learning the differences between evidences and imagination helps us appreciate the true beauty of science. The first myth is that the time is exactly the same everywhere. As we learned earlier, Einstein's theories showed that the time is affected by the gravity and speed, although these effects are usually tiny in everyday life. They are real and have been confirmed through many experiments. The second myth is that the time travel has already been proven. Forward time travel through time dilation is supported by experiments involving fast-moving particles and precise clocks. However, backward time travel remains hypothetical, and there is no verified evidences that humans have traveled into the past. Another common myth is that the time can simply be frozen. Movies often shows characters stopping time while continuing to move themselves. Modern physics provides no evidence that such a situation is possible for an ordinary objects. People also believe that black holes pull in everything like giant vacuum cleaners. In reality, the black holes attract objects through gravity, just like any other massive object. If our sun were magically replaced by a black hole of the same mass, Earth would continue orbiting in nearly the same way. The difference is that there would be no sunlight. Some believe that all clocks measure time perfectly. Scientific experiments shows that the clocks experience tiny differences depending on gravity and the motion. Atomic clocks are incredibly accurate, but even they require careful calibration. Another misunderstanding is that scientists already know everything about the time. The truth is almost the opposite. Scientists misunderstand many practical aspects of time very well, but fundamental questions such as why time has a direction or whether time is fundamental remains active areas of research. Science fiction often suggests that faster than light travel is already possible. According to current scientific evidences, nothing with the mass has been observed exceeding the speed of light in a vacuum. Researchers continue exploring new ideas, but extraordinary claims require extraordinary evidences. These myths remind us that curiosity should always be balanced with critical thinking. It is wonderful to imagine exciting possibilities, but science progresses by testing ideas through observations and experiments. The positive lesson is that the learning never ends. Every myth replaced by evidence brings humanity closer to understanding the universe. Instead of accepting information without question, we should ask, investigate, and evaluate reliable evidences. Be grateful for the scientific methods. It allows people from different countries and cultures to work together, test ideas honestly, and gradually improve humanity's understanding of reality. Even after correcting many myths, some of the biggest questions about the time remains unanswered. Let's explore the mysteries that scientists are still trying to solve. Every answer in the science opens the door to new questions. Science has answered many questions about the time, but some of the most important mysteries remain unsolved. These unanswered questions inspire researchers around the world to continue exploring the universe with curiosity and determination. One of the biggest mysteries is what is time itself? We know how to measure time accurately and we understand how it behaves in many situations. However, scientists still debate whether time is a fundamental part of reality or whether it emerges from deeper physical processes. Another major question is why does time move only forward? The laws of physics often work equally well when written forward or backward in the time, yet our daily experience clearly moves from the past towards the future. Entropy provides an important explanation, but researchers continue studying why the universe began in such a highly ordered state. Scientists also hope to unite general relativity and quantum mechanics into one complete theory. General relativity describes gravity and the large scale structure of the universe extremely well. Quantum mechanics explains the behavior of tiny particles with remarkable accuracy. However, combining these two theories remains one of the greatest challenges in the modern physics. Many researchers believe that solving this problem may also reveal the true nature of time. Another fascinating question concerns the Big Bang. Did time itself begin with the Big Bang, or was there an earlier stage that current theories cannot yet describe? New observations from advanced telescopes and future space missions may help answer this question. Researchers are also searching for a theory of everything, a single framework that explains all fundamental forces of nature. If such a theory is discovered, it may provide a much deeper understanding of time than we have today. A common misconception is that unanswered questions mean science is weak. In reality, unanswered questions demonstrate the strength of science. Scientists openly acknowledge uncertainty and continue collecting evidences instead of claiming certainty without proof. This willingness to improve ideas is one of the reasons science has achieved such remarkable success. History provides many examples. There was a time when people did not understand electricity, gravity, or the structure of atoms. Through careful observation and experimentation, these mysteries gradually became clear. Today's unanswered questions may become tomorrow's discoveries. This teaches us an important lesson for everyday life. We do not need to know every answer immediately. Learning is a continuous journey. Patience, curiosity, and honesty are more valuable than pretending to know everything. Be grateful that humanity has the freedom to ask difficult questions. Every generation contributes new ideas, new technologies, and new discoveries that expand our understanding of the universe. The search for knowledge is one of the greatest adventures of all. Every generation has understood time a little better than the one before. The story of humanity's understanding of time is also the story of human curiosity. From the earliest civilizations to today's space missions, people have tried to answer one simple question: how can we understand and measure the time? Thousands of years ago, ancient civilizations carefully observed the movement of the sun, moon, and stars. Farmers depended on these observations to know when to plant crops and when to harvest them. Ancient Egyptians, Babylonians, Chinese, Indians, Greeks, and many other civilizations developed calendars based on astronomical observations. Sorry. These early systems helped organize agricultural, trade, religious festivals, and daily life. As civilization developed, people invented tools such as sundials, water clocks, and hourglasses. These inventions allowed time to be measured more consistently than simply observing the sky. Although they were not perfectly accurate, they represented major scientific achievements for their time. During the Middle Ages, mechanical clocks appeared in Europe and later spread throughout the world. Public clocks changed the way cities operated. Work schedules, transportation, education, and business became more organized because people could now coordinate activities with greater precision. In the 17th century, Sir Isaac Newton proposed that time flowed at a constant rate throughout the universe. For many years, this idea successfully explained the motion of planets and everyday objects. Newton's concept of absolute time dominated scientific thinking for more than 2 centuries. Everything changed in the early 20th century when Albert Einstein introduced the theories of special and general relativity. Einstein showed that time depends on speed and gravity. This revolutionary idea transformed physics and continues to influence modern science and technology. The invention of atomic clocks during the 20th century brought another major breakthrough. Today, these clocks measure time with astonishing accuracy, supporting GPS navigation, telecommunications, banking systems, scientific experiments, and space exploration. The journey is still continuing. Modern physicists use particle accelerators, space telescopes, gravitational wave observatories, and quantum experiments to investigate the deepest mysteries of time. Questions about quantum gravity, dark energy, and the beginning of the universe remains open. This historical timeline reminds us that the knowledge grows gradually. Each generation builds upon the discoveries of earlier generations. Progress rarely happens overnight. Instead, it is the result of patience, observation, cooperation, and continuous learning. The personal lesson is inspiring. Every person has the opportunity to contribute to knowledge, whether through science, education, creativity, or helping others. Small discoveries today may become major breakthroughs tomorrow. Be grateful for the generations of thinkers whose curiosity has improved life for billions of people. Their legacy reminds us that learning is one of humanity's greatest strengths. Many of these discoveries were confirmed through remarkable scientific experiments. Let us now explore some of the most important experiments that changed our understanding of time forever. Science becomes stronger when ideas are tested by the experiments. Science is built on evidences. A theory becomes trustworthy not because it sounds convincing, but because experiments repeatedly supported it. Our understanding of time has grown through many remarkable scientific experiments. One famous experiment took place in 1971 when physicists Joseph Haffel and Richard Keating carried highly accurate atomic clocks aboard commercial airplanes. After flying around the world in different directions, they compared the traveling clocks with clocks that had remained on the Earth. The results matched Einstein's predictions. The moving clocks show the tiny differences, confirming that speed influences the passage of time. Another important example comes from the Global Positioning System. GPS satellites orbit Earth at a high speed while also experiencing weaker gravity than people on the ground. Engineers must correct both spatial and general relativity effects every day. Without these corrections, GPS errors would grow by several kilometers daily. Every successful GPS navigation provides practical evidence that Einstein's theories work. Particle accelerators offer another powerful demonstration. Scientists accelerate tiny particles called muons and other subatomic particles to extremely high speeds. According to relativity, these particles should experience time more slowly. Experiments consistently confirm this prediction, providing some of the strongest evidences for the time dilation. Modern laboratories also uses highly precise optical atomic clocks to measure tiny differences in the gravity. Scientists have shown that the clocks placed only a short distance apart vertically can measure slightly different rates of time because gravity changes with height. These experiments continue improving our understanding of relativity and may eventually help map Earth's gravitational field with extraordinary precision. Space exploration has also contributed significantly. Satellites, telescopes, and space probes collect enormous amounts of information that help scientists study gravity, cosmic expansion, and the age of the universe. Observatories detecting gravitational waves first directly observed in 2015 opened an entirely new way of studying space-time itself. A common misconception is that scientific theories are based mainly on opinion. In reality, theories become accepted because they survive repeated testing by independent researchers using different methods. If reliable evidence contradicts a theory, the scientist revises or replaces it. This willingness to improve ideas is one of science's greatest strengths. These experiments teaches us an important lesson about critical thinking. Good decisions are based on evidence rather than assumptions, whether in science, education, business, or everyday life. Testing ideas carefully usually leads to better results. Be grateful for the researchers who dedicate years to careful experiments. Their patience, honesty, and commitment to evidence help humanity understand the universe more clearly and improve technologies that benefits millions of people. Scientific discoveries are fascinating, but they become even more meaningful when we apply them to our daily life. Let's see how understanding time can improve the way we live. After exploring black holes, relativity, atomic clocks, and the age of the universe, it is worth asking a practical question. What does all of this mean for our daily life? How you spend your time is how you spend your life. Although most of us will never travel near the speed of light or visit a black hole, time remains one of the most valuable resources we possess. Every person receives the same 24 hours each day. The difference between people often lies not in how much time they have, but in how they choose to use it. Good health depends on time. Regular sleep allows the brain to organize memories and repairs the body. Exercise performed consistently over time improves physical and mental well-being. Healthy habits may seem small each day, but their benefits grow over months and years. Learning also depends on the time. Knowledge is rarely gained instantly. Reading books, practicing skills, asking questions, and learning from mistakes requires patience. The world's greatest scientists, artists, athletes, and leaders all invested thousands of hours developing their abilities. Relationships grow stronger through shared time. Families, friendships, and communities become healthier when people spend meaningful time listening, supporting one another, and creating positive memories. Expensive gifts often matter less than genuine attention and care. Time also influences decision making. Rushing important choices can lead to mistakes, while thoughtful planning often produces better results. At the same time, waiting forever can prevent opportunities from being taken. Wisdom lies in balancing careful thinking with timely action. One challenge of modern life is distraction. Smartphones, social media, and constant notifications can consume hours without providing lasting satisfaction. This doesn't mean technology is bad. Technology is a powerful tool when used wisely, but it should support our goals rather than control our attention. A common misconception is that successful people somehow have more time. In reality, they have the same number of hours as everyone else's. What often differs is how they prioritize their activities. They focus on learning meaningful work, relationships, and continuous improvement. This lesson connects beautifully with everything we have learned throughout this video. Whether we study atomic clocks or daily routines, time remains precious because it cannot be replaced. Once a moment has passed, it becomes part of history. Be grateful for every opportunity each new day brings, even a small positive actions, helping someone, learning something new, exercising, reading, or expressing kindness can create lasting benefits over time. The greatest investment we can make is not merely in the money or possessions, but in using our time to build knowledge, character, relationships, and purpose. Time does not change people, it gives them opportunities to change themselves. Throughout this video, we have explored some of the greatest scientific discoveries about the time. We learned that gravity can slow time, speed can change time, atomic clocks can measure time with incredible precision, and the universe itself has a fascinating history stretching back approximately 13.8 billion years. But perhaps the most important lesson is not found in physics alone. It is found in how we choose to live each day. Time is the only resource that every person receives equally. Every day contains 24 hours, regardless of age, wealth, nationality, or profession. What makes life different is not the amount of time available, but the choices made during that time. One powerful lesson is that small actions become great achievements through consistency. A person who reads a few pages every day can finish dozens of books in a year. A student who studies regularly often learns more than someone who studies only before an examination. A small daily habit, repeated patiently, can produce remarkable results over months and years. Time also teaches us patience. Many of nature's greatest creations require time to develop. A mighty tree begins as a tiny seed. Mountains are shaped over millions of years. Scientific discoveries often require decades of careful research. Success rarely appears overnight, even though it may seem that way from the outside. Another important lesson is that mistakes are not wasted time. If we learn from them, every challenge provides experience, and experience improves judgment. History shows that many famous inventors, scientists, and entrepreneurs faced repeated failures before achieving the success. The key was not avoiding mistakes but continuing to learn. Modern life often encourages people to stay busy without asking whether they are spending time wisely. Being busy is not always the same as being productive. Meaningful work, learning, rest, relationships, and service to others create lasting value. Respecting the time of other people is another sign of a good character. Arriving on time, keeping promises, listening carefully, and appreciating another person's efforts all demonstrates respect and responsibility. The greatest lesson is to live in the present. We learn from yesterday and prepare for tomorrow, but our actions are possible only today. The present moment is where knowledge becomes action, dreams become plans, and kindness becomes reality. Be grateful for every sunrise because it brings another opportunity to grow, help someone learn something new, and become a better version of yourself. Time continues in moving forward, but each new day offers a fresh beginning. After understanding the lessons of time, let us reflect on the greatest gift that time gives every human being: the opportunity to live with gratitude. The richest person is not the one who owns the most, but the one who values each moment the most. As we can come to the end of this journey, it is worth reflecting on one simple truth: time is life's greatest gift. We often focus on earning money, buying possessions, or achieving success, but none of these things can replace even a single moment that has already passed. Every day begins with the gift of time. We cannot store it, borrow it, or recover it once it is gone. This makes time one of the most precious resources in existence. Gratitude changes the way we experience time. When we appreciate the present moment, we become more aware of the people, opportunities, and experiences around us. Instead of constantly worrying about yesterday or tomorrow, gratitude helps us recognize the value of today. Think about the people who have influenced your life: parents, teachers, friends, mentors, or colleagues. Their greatest gift may not have been money or possessions. It was often the time they spent teaching, encouraging, listening, and caring. Time shared with others create memories that can last a lifetime. Scientific discoveries also remind us to feel grateful. Thousands of researchers across generations have dedicated their life to understanding the nature. Because of their efforts, we benefit from modern medicines, transportation, communication, space exploration, and technologies such as GPS that relies on accurate measurements of the time. We build our future upon the knowledge and dedication of those who came before us. A common misconception is that the gratitude means ignoring life's challenges. In reality, the gratitude and ambition can exist together. We can appreciate what we have while continuing to work towards meaningful goals. Gratitude encourages optimism without preventing progress. One practical way to value time is to spend it intentionally. Reading, exercising, helping others, learning new skills, creating meaningful work, and strengthening relationships often provide deeper satisfaction than endless distractions. Every hour invested in the personal growth becomes part of a stronger future. Another valuable habit is to reflect at the end of each day. Ask yourself simple questions. What did I learn today? Whom did I help? What am I thankful for? What can I improve tomorrow? These questions encourage continuous growth while keeping life balanced. The universe is approximately 13.8 billion years old, yet each of us experiences only a small part of that incredible history. Rather than seeing this as insignificant, we can see it as inspiring. During our brief time, we have the opportunity to learn, love, create, discover, and leave the world a little better than we found it. Be grateful for your family, your health, your opportunities, your education, and your curiosity. Most importantly, be grateful for time itself because it makes every other gift possible. As we conclude, let us bring together everything we have learned and look ahead with curiosity, hope, and purpose. We began by asking a simple question: what is time? Along the way, we discovered that the answer is far more fascinating than most people imagine. Time is not merely what a clock measures, it is deeply connected with space, gravity, motion, energy, and the evolution of the universe itself. We learned that Einstein transformed our understanding by showing that the time is relative. It changes depending on gravity and speed, and these effects are not just theories, they are confirmed every day Through atomic clocks, satellites, and GPS technology, we explored why time always appears to move forward, how black holes affect time, and why astronauts traveling at very high speeds experiences time differently. We also discovered that the human brains experiences time in unique ways. Childhood often feels longer because everything is new, while familiar routines can make years seems to pass quickly. Fear, excitement, concentration, and mindfulness all influences how we perceive the time. Our journey then expanded into the history of the universe. We explored the Big Bang, the age of the cosmos, unanswered questions about what happened before the universe began, and the ongoing search for a deeper understanding of reality. We saw that science does not claim to know everything. Instead, it continues asking better questions and seeking better evidence. One of the strongest messages through this video is the importance of critical thinking. Curiosity is valuable, but it should always be guided by reliable evidences. Science grows stronger because ideas are tested, challenged, and improved over time. Beyond science, time teaches us valuable life lessons. Every achievement begins with small daily actions. Every relationship grows through shared moments. Every skill improves with consistent practice. Every mistake becomes meaningful when it helps us to learn. Remember that success is not measured only by how much we accomplish, but also by how wisely we use the time available to us. Kindness, honestly, learning, creativity, and gratitude creates lasting value that extends beyond material success. As you leave this video, I encourage you to remain curious, read more books, ask thoughtful questions, explore science, history, philosophy, and the natural world. The universe is full of mysterious waiting to be understood, and every discovery begins with someone asking why. Finally, take a moment to appreciate today. The past cannot be changed, and the future has not yet arrived. The present moment is where we learn, grow, help others, and shape the future through our choices. Thank you for spending your valuable time with me. I truly hope this video has inspired you to see time not only as a scientific concept, but also as one of life's greatest gifts. If you enjoyed this video and would like to explore more fascinating topics about science, history, psychology, technology, and the universe, please support the channel by liking the video, sharing it with others, and subscribing it to the channel. Until our next journey together, stay curious, keep learning, and make every moment count.